Okay, so now let's try to answer question 2. Okay, A, B, C, D is a parallelogram with vertices A, B, C, and D. Okay, determine the length of AC in simplest said form. So let's try to determine. So 2.1, it will be AC, A to C. What is A here? Oh, this is A. Yes, A to C. So it will be the square root of C. It's -2 here. Sorry for that. So A to C, it will be 0 plus 4 squared plus -2 minus 6 squared. And then when we use a calculator for this one, this will be 4 squared, right? Plus -8 squared. So whenever you use your calculator, this will be the square root of 4 squared plus -8 squared. And then the answer is 4 square root of 5. 4 square root of 5. So this will be your answer. 2.2, determine E, the midpoint of AC. So it's basically the midpoint. So it means we have a line. Sorry. I'm really sorry. I should have used a rule, okay? I should have used a ruler. Unfortunately, I do not have a ruler with me here. But let me try to use a pen, okay? So yes, something like this. So now we can find the coordinates here. The coordinates of this point. They're saying it's point E or point E. Okay, X and Y. So the midpoint theorem. No, sorry, not the midpoint theorem. The midpoint formula. I know I'm used to that theorem. So yeah, sometimes it give me a hard time. But let me finish up this one. Yeah. So this one will be the midpoint AC, which is equals to the x1 plus x2 divided by 2, y1 plus y2 divided by 2. So you can just choose which one to start with. You can say x1 is -4, it's fine. -4 plus 0 divided by 2 as 6. 6 plus is basically minus 2, okay, divided by 2. So now -4 plus 0, it's -4 divided by 2, it's -2. 6 minus 2, it's 4 divided by 2 is 2. So this will be your answer. And then let's move to 2.3. Determine the coordinates of D, the coordinates of D. To determine the coordinates of D, it's very easy, guys. There's no need for you to use the midpoint formula. You can just check. Okay, if you are told that this shape A, B, C, D is a parallelogram, it means that -4 plus 0, it is equals to 3 plus this x. Let me write it down, okay? For 2.3, -4, this -4 plus 0, it is equals to 3 plus our value of x. So basically here it's x1 plus x2, which is equals to x3 plus x4. So our x1 is -4, our x2 is 0, x3 is 3, x4 is x. Therefore, you solve for x. So x will be equals to -4 plus 0 minus 3, which is equals to negative 4 plus 0 minus 3, it's minus 7. So x, it's minus 7. Let's do it for y. For y, you can say, for our y, it will be y1 plus y, okay, y1 plus y2, it is equals to y3 plus y4. So our y1, I can say it's 6. It's 6 plus our y2, I can say it's negative 2. So it's basically minus 2. Yes, minus 2, positive times negatives minus, equals to 5 minus or plus y. Yes, so it's 5 plus y. It's 6 minus 2 equals to 5 plus x. So I used a minus because this is negative 2. 6 minus 2, it's 4, which is equals to 5 plus y. So y, it is equals to 4 minus 5, which is equals to negative 1. So y, it's negative 1. So basically here we have negative 7 and negative 1. So let's check if this is true or this is correct. Negative 4 plus 0, what do you get? You are getting a negative 4. So let's see if ever from D to B, it will be equals to A to C for the x values. 3 minus 4. 3 minus 4, you are getting minus 4. So it is equals to the x value for xc, for AC, I mean, because if ever you replace you replace by xc here, you are getting negative 4, getting negative 4 whenever you use this negative 7. Yes, so it's correct. It's negative 7, negative 1. 2.4, determine the equation of a straight line drawn from B perpendicular to AC. Oh, from B perpendicular to AC, okay? From B perpendicular to AC. It means that actually this line here, I should have drawn from B to this point here, so that it can be perpendicular, because they never told us that it's from B to E, right? Sorry for that. So if ever it's perpendicular, it means you have 90 degrees here. So now you can be able to determine the equation of the line drawn from B perpendicular to AC, okay? Equation of this line. So the equation of this line, it's easier. So you need to make sure that you know the gradient of AC, okay? So let me try to determine the gradient of AC. The gradient of AC, it is equals to negative 2 minus 6 divided by 0 plus 4. So it's negative 8 divided by 4, which is negative 2. Now, just because AC is perpendicular to BC, or BC is perpendicular to AC, it means the gradient of AC multiplied by the gradient of B to this point here. Let me name this point F. Yeah, let me say F. Okay, BF must give us negative 1. Okay, so AC is negative 2. Negative 2 times the gradient of BF, which is equal to negative 1. So the gradient of BF, sorry, the gradient of BF, it is equals to, here you divide by negative 2, you divide by negative 2, and then the answer will be half. So the gradient of BF, it's y, or it's half, so you have y, it is equals to half x plus c, because this half is for m. And then now you can determine the coordinate of c, just because this line it has the coordinates of b 3 and 5. You can replace by this 3 and 5 for y and x, so that you can get c. So c will be equals to 5 minus half multiplied by x. X is 3. So whenever you use your calculator, it will be 5 minus half multiplied by 3, which is equals to 7 divided by 2. So therefore the equation will be y it is equals to half x plus 7 divided by 2, and then you are done. This will be your equation. Thank you very much, guys.